So this is the seaborn way of doing a scatter plot that we just finished commenting before the pause. And that's what happens, which is basically the same thing that happened with matplotlib. And again, we can do any customization we have seen with matplotlib, that's the same. We just put a logarithmic scale in the diameter. I don't remember if it was the case also for the matplotlib version, but there's nothing much to say. Then another kind of plot is the time series. Technically, the time series is not a different plot. It's a line plot, okay, or even a scatter plot if you want, but usually it's a line plot that simply has some form of measurement of the passing of time in the x-axis, okay? So why time series usually deserve a special mention? Simply because of the preprocessing that is involved. As we already seen, usually to properly interpret daytime data, you need to do some preprocessing. But that's the only reason why time series are usually mentioned separately in data visualization. In the broader, let's say, realm of data science, they're including, for instance, machine learning models, usually time series analysis deserves a special mention because you have correlations, okay, across time. So you need to explicitly take into account time. So many methods for doing regression analysis or prediction analysis or whatever usually are tuned to time series data in some way. Again, so time series is not a particularly new plot. It is a point or a line plot usually, but the difference is in how you encode the temporal information on the x-axis. So let's take a look at an example with this sort of stock data. Also, this one is something that I believe we already seen. So we have this data set, another CSV file that tracks a long time different features of the stock market. I don't remember which, maybe Tesla. Yeah, Tesla stock price, so it could be Tesla. And again, conceptually, there's nothing new. These are a list of data points. You can plot the data on the x-axis and then the value you want on the y. But to properly interpret and order the x-axis, you need to preprocess this temporal information. So we import pandas, we import matplotlib as usual, we load the dataset as usual, and that, as we already seen in a previous example, the same dataset, I believe, we explicitly tell pandas how to interpret a given piece of data. Okay, if you remember in the example we already did, we first tried to let pandas automatically infer the data type. He did well in some data type, in some columns, not in others. So we need to, even at that time, we needed to fine tune and manually intervene. So this time we limit ourselves to the two columns that we want to plot. So we want to plot the open value as a floating point, so a decimal value, across the data time as a completed data time information. And basically the only novelty is here in the preprocessing of the data. Then we create, as usual, the figure. So we are working with the object-oriented style with matplotlib. On the x-axis, we want to put the time steps. On the y, the prices. We use this marker, this size, this line style, just some customization. The thing that is worth noting, because usually it is useful with time series data, is that we can rotate the labels. We can do this both in the x-axis and in the y, and this is useful because otherwise the labels can get overlapped one with each other. So by rotating them, we can avoid the overlap. This tight layout is just, let's say, a look and feel thing that you may want to use sometimes. Let's see if there is any effect in this specific example. Usually it compacts the plot a bit. So it may have an effect or not depending on the plot. Here, honestly, I don't see a specific effect, but usually it is used to, let's say, avoid blank space as much as possible around the plot. Again, nothing particularly relevant, but for the pre-processing. Seaborn is similar, obviously. We are using a line plot, so that specific plot. In the X, we put the time steps. In the Y, we put the prices. More or less same configuration, same rotation, and we can expect a similar plot. Okay. What changed? Basically, I would say the only thing that changes is that here the dots have a white border. I would say is the only thing. Maybe the labels. Maybe in matplotlib we didn't have the automatic labels. Here we do have, if I remember correctly. Another kind of graph is the pie chart. Seaborn does not provide pie chart. Okay, obviously you can still style a plot from Seaborn because Seaborn uses matplotlib under the hood, but there is no explicit method in Seaborn to do a pie chart. So basically you fall back to matplotlib anyway. And in fact, we only have the matplotlib example. We import matplotlib. We don't need pandas or numpy because we are generating the data simply with Python. We want to display I don't know what, okay, some random values for some random countries. We want percentages, okay, so we want, based on these values, let's say they are the market share of something. So we want to plot the market share in percentage. So we create a new list where we take all the values and we divide it by the sum, and then we multiply by 100 to get the relative percentage of market share given these values. And then when we want to plot with a pie chart, we are using here the procedural way, so the pie plot way. We want to plot the values, okay? We don't have another axis. In a pie chart, there is only one axis, basically. So we want to put the values, the labels should be the country, and this is a way to format the numbers that are automatically put into the slices of the pie chart. Okay, so why here we do have 24.0%? Because of this parameter. If we remove it, something else happens. Okay, we are not showing anything in this case. Here instead we are basically telling we want one decimal place and the whole integer part. That's what we are basically telling Python to do. Again, how can these basically random symbols make sense? By looking at the documentation. There is no other answer, okay? And there is no chance that you remember, unless you do it every day, there is no chance you remember this kind of gibberish, okay? Again, in Seaborn, there is no actual pie chart. Then we have the block spot that, as we mentioned, are usually used to show data distribution. So they are very useful for probabilistic data, statistical data, okay? And we want to compare distributions. The usual example of the miles per gallons, the motor kinds. So we have, we want to come up with this box plot. And if nothing changes, this time the appearance is quite different from comparing matplotlib and Seaborn. Okay, so let's check it out. Again, in matplotlib, we have our box somewhere here. So again, this time we have a data set, which is these motor cars. Okay, this is the data set. We have the model of the car, miles per gallon, number of cylinders, this displacement value that I don't know, the horsepower, I don't know what that is, I don't know what, maybe this is weight, I don't know. So this, all of this data, okay? So we load the data useful. And now we filter our dataset. This is, again, this is pre-processing, okay? We want to obtain specific parts of the dataset, so we are basically filtering it. If you remember, in fact, this is a filtering operation. This in particular is a filtering operation, okay? So within the square brackets that we know we can use with a dataset to access some columns, okay, we can put a filter. We learned this in our overview. So basically what I'm saying here, or we can also select all the rows, for instance. So here what we are doing is, from our original data frame, whole data frame, only select the rows that satisfy this condition. So that all the rows that have 4 cylinders. So if we look at our data, for instance, this row will be selected, row 4. Row 9 will be selected, okay? The same for 6 cylinders and 8 cylinders. Then we don't want the whole row, so all of the data, all of the features. We only want the mile per gallons column. So when you filter the rows, only take this column. That's it. So we end up with the miles per gallon with only for vehicles with 4 cylinders, the miles per gallon only for vehicles with 6 cylinders, and the same for 8. Then the data that we want to plot is the list of these 3 data series. 4 cylinders, the 6 cylinders, the 8. And then we use matplotlib to plot this data, 3 data series, so 3 boxes, each with their own labels. Here, the matching between the label and the data series is done using the order, okay? They must compare with this, they must appear with the same order. And that's what we end up with in matplotlib. So we have our plots, we have our cylinders, that is the labels that we explicitly put, so the tick labels. And here is the amount of data, okay, that is there, the values, the distribution of values. As we said, in box plot, we have the percentiles. We can change them. By default, you have the 75, 50, and 25 percentiles, okay? But you can change them. You can get, I don't know, 90 percentiles, whatever you want. We have the standard deviation as the whiskers. And we have the outliers, which are dots. These are points that are outliers, okay? So outliers mean they are very peculiar. They have very peculiar values. And with seaborn, how we can plot a box plot, here it is easier. We don't need the pre-processing that we needed for matplotlib. Here we don't explicitly extract the data from manually extract the data from the data frame. We just load the data frame, and then we tell pandas that seaborn that the data is in the data frame, that the x-axis cares about the cylinder column. Obviously, the name must match exactly. The y-axis should consider the MPG column feature. And here we are changing the palette. So I randomly put an example of changing the color palette. We are using a colorblind-friendly palette. And we are changing the color of the boxes depending on the cylinder. This is not strictly required because the different cylinders are also put in the x-axis and we still have 3 different boxes, okay? It is just to show you some customization. We don't want the legend because it is already clear. And we set the 2 labels. So let's see what happens and then let's try to change something. So this is what happens. This is a colorblind palette. Seaborn automatically rotates color. We have our 3 categories, 3 boxes. And what, for instance, if we didn't change the hue? Well, the plot will be less colored, but it will be clear anyway, because we still have 3 boxes. Okay? We still have 3 boxes. And they are still colored because Seaborn rotates the palette. Okay? Here, the palette has no effect. This is the standard palette. What if we put the legend? Let's see what happens, just to check. The legend is redundant because we already have the X label that tell us what the coloring is about. So in this case, the legend isn't really needed. The plot is the same. The boxes are larger in Seaborn by default. They are thinner in matplotlib, but again, it is just a matter of taste. As you can see, sometimes one of the 2 ways is easier. This time, for instance, Seaborn didn't require us to do the preprocessing, to manually extract the data for each cylinder. So for this particular plot, Seaborn may be easier to use. Then we have an heatmap, which is useful, as we already said, to show correlations, distances, similarities between stuff. And here we have 2 examples with, I don't remember which dataset, but we will check. The distances between cities. So the same we have already seen. So we have a list of cities, another list of cities, and we plot their reciprocal distances as a heat map. Here I put the less effort in the configuration on purpose to show what the default is. So basically here we are loading the data and we need to tell pandas that city is the index, okay? Otherwise, pandas creates a novel index, which is a numerical 1. And then with seaborn, for instance, okay, we simply use method cluster map and we pass the whole dataset. Let's see what happens. So we get quite a lot with 0 effort, basically. So let's try to analyze the picture, which is actually a bit big, so they cannot conveniently resize. Okay, so what do we get? Well, we get the heat map, okay, fine, with the labels already there. The cities are ordered in the same way, not because of magic, but because they are ordered in the same way in the original dataset. So, as we expect, the main diagonal has all zeros, okay, because it is comparing one city with itself. We get the legend. So, darker colors means closer cities. Lighter colors means more distant cities. And we also get for free this sort of dendrogram, which is called a dendrogram. It is a sort of clustering visualization technique, which in this case doesn't really tell us much, but something it tells us. We will see dendrograms, okay, we will mention them when speaking about clustering, so this is just an anticipation. When you see these lines, so for instance, these big lines, you can see that there is a cluster here. What is a cluster? A group of cities that have more or less the same distances from each other. So, for free, seaborn give us a dendrogram of the distances. Here there is another cluster, and in fact I can see here this box. Here, all this area can be regarded as a cluster of similar cities, so we have another box here. Okay, so we get for free this sort of dendrogram. What do we get with matplotlib? Much less. Again, we load the data and we tell matplotlib what the index is. In matplotlib, we cannot directly use a data frame, a pandas data frame to plot an heat map. We need to do a bit of work, a bit of pre-processing. We need to convert the data series in a NumPy array. Why? Because matplotlib heatmap works this way. There is actually no real why. And the method that we are using is a bit peculiar. In matplotlib, there is no heatmap. That's why we are using NumPy, because we are more or less cheating. We are using a method which is called imShow. It is actually a method to show an image based on an RGB representation of the colors. So we are cheating. There is no explicit heatmap in matplotlib. So for instance, for heatmaps, seaborn is the preferred library. This is what we get with matplotlib. We can try to put a legend in it, because that's that's a bit ugly. We don't get the labels, we don't get the legend. Okay, let's forget about the dendrogram, which maybe we don't need, but we get almost nothing. So let's try to put at least some legend. Let's see what happens. I won't be confident. There is no legend, basically, because we need to tell matplotlib, look what. How did you interpret the numerical data, because there are distances in the plots, as colors? So basically here the takeaway is don't use matplotlib for heatmaps. You need to do much work to get the same result as you get for free with seaborn. Okay, you can, if you're curious, go to the documentation, you can find many examples. So for instance, if I look for matplotlib heatmap, I'm sure that I get some sort of examples. You can get a very nice result, but you need to do some work. Okay? The matplotlib documentation is very good. Okay? It's extremely good. It is not always the case for open source projects, but matplotlib grow big in the years. The documentation is very good. Is a reference for documentation, because they explain you all the things, technically and non-technically. They give you examples. They point you to more examples. They point you many times. They point you to, let's say, a Google Colab with the code that you can try. So it's extremely good, the documentation. And just a quick, let's say, a quick digression. Why I refer you to the documentation and not to just Google the thing, which is an approach, okay? Because basically, just Google the thing is fine as soon as you know which version of the library you are using. Because Python is not so famous for do not breaking things when the version of a library changes. So if you just Google things randomly and you open the first result, the second result randomly, you can find a post from some years ago, maybe with another version of the library, and in that version the parameters have a different name, or the method has a different name, okay, stuff like that. So usually the documentation is the truth, okay? That's why I always refer you to the documentation. When the documentation is not so good as in matplotlib or pandas or NumPy, they all have extremely good documentation, maybe you can resort to Google up things, but usually the documentation is the way to go. the official documentation. Then we have a bubble chart, okay, that doesn't really exist, as we already seen. It's just a scatter plot, okay, that is customized to use the size of the dots, the colors of the dots, okay, to show more meaningful things. Let's see an example. Here we are only using seaborn because it is much easier than matplotlib. So if you remember, we had this example with a data set about earthquakes, when it happened, where it happened, the type, earthquake, or maybe there was also something else, the depth, the magnitude, okay, many features about an earthquake. And so what we can do with seaborn and with matplotlib, it will be much more difficult. We load the data, we create a scatter plot, we tell seaborn where the data is, we tell seaborn that we want to put in the x the latitude, in the y the longitude, as hue, as the color, we want to use the depth, and as the size, we want to use the magnitude. That's it. We change the labels, fine. Seaborn is able to do everything else automatically. So the legend, everything you want. Okay. With matplotlib, you will need, as we have seen while customizing the scatter plot with colors, you will need to do all of this customization by hand. You will need to create the legend by hand. You will need to create a color map and a size map by hand. Okay, all by hand. Here instead, with seaborn, the library takes care of this. Then, if you want, you can customize the colors, the sizes. You can customize as you wish. But if you don't want to customize it, seaborn in just one line gives you the result. So, why sometimes I show the examples with both matplotlib and seaborn? When they are comparable, okay? The amount of effort you need to put into the plot is comparable between the two. When there is a clear winner, I put only the clear winner. Okay? So that you know that if you want to draw an heat map, or if you want to draw a bubble chart, the go-to choice is seaborn, not matplotlib. What else you can do? Well, basically anything you want. If you are curious about data visualization, I suggest you to look for seaborn or matplotlib galleries. In the official documentation, we have a gallery of examples, okay, in which you can see all the wonderful things you can do. This, for instance, is a violin plot that more or less has the same information as a box plot. You can find the examples. This is a box plot with also the data points. So it is a sort of scatter plot overlap with a box plot. So I can get a sense of the data distribution with the box plot, but also how the actual data is distributed with the actual data points. This is a way to show the means of these measurements. So you can do very, very fancy things. These are called sometimes contour plots, okay? Like if you wanted to draw a map, okay, with the altitude of a mountain. So if you are curious about this topic, look at the documentation because you can do very, very fancy things, okay? You can compose different plots in the same picture. So if I want to put many plots in the same picture, I don't necessarily need to do different figures with matplotlib and then put them together with Photoshop. I can do that with matplotlib directly or with seaborn. Here we have the sort of plot that we mentioned. I think this is a scatter plot with also on the diagonal basically a histogram for continuous data, so which is called a KDE plot usually. This is a fancier heat map with sort of continuous data. Okay, so many plots. This is again a violin plot. This is a questionable regression line put over a grouped scatter plot. Okay, many examples, and with matplotlib is the same. This is a very fancy scatter plot, and also in matplotlib you have the same. You have a gallery with examples. They are very useful because usually, depending on the data you have and depending on what you want to show, the best plot is a different plot. So that's why it's useful to have this sort of galleries. This is something like, I think, control theory, maybe Nyquist something. This can be maybe a spectral analysis of something. I'm just guessing, okay? Well, this is just a showcase, a snowflake. But you can have these bar charts that are very convenient to show, for instance, the proportion of things. This is a questionnaire. So for each question, you want to show quickly all of the different answers. That's very effective. And also the good thing is in matplotlib you also have specific plots that are just meant to show you some customization. So here, for instance, you have the list of symbols you can use in the marker option, in the marker parameter. These are the markers. You can put all of these symbols. Basically, yeah, everything you may want to do is here. You can create a barcode, whatever you want, okay? Also, I think 3D plots are covered somewhere. Let's check. Pie charts. This sort of radar. This is a radar plot. And you have example categorized, okay? So if you want to work with labels, with text, okay, where to start? Look at the examples. They explain everything, okay? Many times it's easier to look at the examples instead of going to the documentation. I wanted to show you if there is a 3D plot, but I don't find it. So. Oh, access grid. 3D plotting. Okay. Then you can have surfaces. So this surface. Different kinds of things. What? You can also do animations. But for animations, there are other libraries which are probably better, but you can do them. Okay. I included another example, which is a sort of advanced example. Okay, we won't go into many details, but it's a sort of advanced example because we do a lot of customization. So this is a data set about, if I remember well, we will check in the code, but this is a plot that shows the gold, silver, and bronze medals in Olympic Games for Italy. And so you have this bar plot that is colored according to the color of the medal, okay? And in each bar, you have different sections whose size is the number of medals. And they are stacked so that the whole height of the bar is the total number of medals. And you also have an annotation. And we will see this is also an interactive plot. We will check this out because this annotation is not statically put there, but depending on where you hover over with your mouse, okay, you have this annotation. So we won't go into every detail, but this is just to show you that you can do this sort of advanced things in matplotlib, for instance. So we do load the data. The data is this one, medals. So we have for every year, for different sports that I cannot interpret in this specific label, different disciplines, the kind of medal, the country, the athlete, and many other things. From this whole dataset, we only need a subset, okay? We care about Italian athletes, and we want to group Italian athletes. So we need to do a bit of pre-processing. Let's group, okay, data by country and year. So we want all the Olympic medals in 1970 for Italy, Switzerland, Norway. Then 1974, again for Italy. So we have a hierarchical grouping, okay? The year, and within the year, the country. And we want to check the number, okay? Why? Because we want to check the number of medals. Then we filter, okay? Then we filter the original DF. So the original. Okay, this is just the number of medals by country and year, a grouping. Then, based on the original DF, we only filter Italian people. Okay? And based on this, we want the medal as a category type. This is just to tell pandas we don't want a string. We want a category. This is a specific value. Then we want again to group Italians medals by year. Okay. And no longer by country, because we already focused on Italy, but by medal type. We don't want an index, and again we want the number of medals. So finally, if we look at this new data frame and filter on the kind of medal, we get 3 data series: the gold medals, the silver medals, and the bronze medals. Now we can do the plot. We create the plot, we configure the axis, and then we need to plot the bars. The bars have a peculiarity. We want to put different bars in the same position, one on top of each other. That's how we created the effect of stacking different colors. Okay? So what we do here is that we tell matplotlib to create a bar with the gold medals, the year of the gold medals as the X, the number of gold medals as the Y, the width of the bar, okay, who cares? The label, who cares? The color, who cares? Now look at how we specify the silver medals. Same things, so the year in the X, the number of medals in the Y, the width, okay, the label, okay, the color, okay, but now we have another parameter bottom. This parameter is where the bar should start. So we are telling pandas the bottom of the silver bar should be the end of the gold one. Gold size values, the number that we got. Were there 12 gold medals? Okay, from then on, the new bar should start. And the same we do for the bronze bar. Where should the bronze bar start? where the gold bar ended plus where the silver bar ended. This is how we do stack bars in matplotlib. So we need to do a bit of work. And this is basically, we already know the annotation thing. So how to put a text box. So here we put an annotation with this text, which is the actual number at this position. Okay, and where to put this. This is a keyword. This is something that we look up in the documentation. Okay, where to put the label. But now the annotation is interactive. There is no annotation here, right? The annotation pops up when I hover over a specific bar. So here, in 1948, Italy got 9 gold medals, 12 silver medals, 10 bronze medals. How to do that? But again, I won't insist too much on this. You need to do a bit of work in matplotlib, and you have two choices. With the matplotlib library, you need to do all of this work. With plotly, you need to do less work. Let's see if I put the plotly example. Yes, is this one. So plotly, which is one of the libraries I mentioned in the slides for interactive part especially, you basically have to do almost, I would say, the same pre-processing. So you read the data, you group by country and year, you extract Italy, you group by year and medal, you extract the specific medals, you create the plots. This is the same, but you don't need to manually specify that you want interactive annotations, because plotly is born with this. What did I did? Okay, I didn't anything wrong. This is just a peculiar thing of matplotlib. So matplotlib automatically gives you this nice visualization. Obviously, you can customize it. With plotly, you can do also non-interactive plots, obviously. And this is another kind of things that you can have. There are many, again, alternatives also to matplotlib, to plotly. Okay? So that's it. When you want to basically, you're doing your project, or you want to check better how a given plot works. So let's say I want to understand better how a box plot works, how an heat map works. Start looking at these very simple examples, then expand with the documentation as needed. Obviously, in the whole process, if you need help, just write me an email and ask me, I didn't understand why we are doing this way, this thing, stuff like that. Okay? But at least in this way, you have some basic example to always check and to always use as a reference directly in your code repository. Okay. Okay, that's it for data visualization. These are the very basics. As I said, there are many more customizations, many more libraries. You can do interactive plots, you can do animated plots, whatever.